Okay, this video is about solving problems with the Pythagorean theorem. You probably remember that the Pythagorean theorem tells us about the sides of a right triangle. Only right triangles, triangles with a 90-degree angle. We know that a squared plus b squared equals c squared, when c, the angle opposite the 90-degree angle, is the hypotenuse. This equation only makes sense if a and b are the two perpendicular legs and c is the hypotenuse. Now there are lots of straightforward problems to solve with Pythagoras. As long as you have two sides of a triangle, a right triangle, you can find the missing side. So let's do that. In this case, 6 and 7 are the a and the b. And remember, we don't really care which is which. It's just these are the perpendicular sides. So 6 squared plus 7 squared equals x squared. We know that x is the hypotenuse because it's opposite the 90-degree angle. We know that 6 squared is 36 and 7 squared is 49. And that equals x squared. And we have to add these together. And we can do it in our heads. 30 and 40 is 70. And 9 and 6 is 15. So we can get 85 equals x squared. Or you can use your calculator. 36 plus 49 is 85. Now in order to solve for x, we have to take the square root of both sides. So the square root of 85 equals x. X is the square root of x squared. Remember that when we take square roots, we usually get two answers, positive and negative. But in geometry, we're solving for the length of a side, and that can't be negative. Now we can approximate the square root of 85 on our calculator. And I'm going to do that right here. And that's approximately 9.22. But remember, the square root of 85 written this way, with the radical sign, that's a perfect answer. There's no error. Once you approximate, you have some error, except the answer can be more meaningful to you. Let's use Pythagoras to solve for y in the next triangle. So in this case, the missing side is not the hypotenuse. The hypotenuse is 13 because it's opposite the 90-degree angle. So we know that 5 squared plus y squared equals 13 squared. 25 plus y squared equals 169. It's really helpful to remember these squares so you don't have to stop and use the calculator each time. So I'm going to solve for y squared. I have to subtract 25 from both sides of that equation. So y squared equals 144. You can do that on your calculator, or you can do it without your calculator. And the square root of 144, many of you probably know, is 12. In this case, we got a perfect square, so it had an integer square root. And these are the very straightforward problems that we can solve with the Pythagorean theorem. You just have to make sure that you set up your equation properly so that the hypotenuse is always in the right place. The sum of the squares of the two legs, the perpendicular sides, equals the square of the hypotenuse. Okay, let's try a harder problem. Here's a problem with a shape you probably haven't seen before. It's a quadrilateral, but what you notice probably is that there are two right triangles here. And you have to find one of the legs, just this x. Now if you start out just looking at that little triangle, you might decide to label this side, I don't know, h perhaps, and then use the Pythagorean theorem. H is the hypotenuse, so x squared plus 6 squared equals h squared. Now that's correct, but that doesn't really help us, does it? Because we don't know what h is, and we don't know what x is. We can't solve for either one of them. We don't have enough information. So what do? Well, let's look at the other part of the diagram. We have another right triangle here. This right triangle has two given sides. One we've labeled h because it happens to be shared with this little triangle. That's a leg. It's not opposite the right angle. One is the other leg, 24 feet, and the hypotenuse opposite the 90-degree angle is 26. So now we have h squared plus 24 squared, the other leg, equals 26 squared. Now I can solve for h. I'm not even going to figure out what the squares are. I'm just going to subtract 24 squared from both sides because I don't really need to know what those individual squares are. I just need to know what 26 squared minus 24 squared is. Because the square root of h squared, h, is the square root of 26 squared minus 24 squared. And if you can resist finding out what the individual squares are, you can just start with a square root, 26 squared minus 24 squared, and your calculator will tell you that h equals 10. Okay, let's try another difficult problem with Pythagoras. This problem doesn't say anything about Pythagoras or finding a missing side. It just says find the area. And this is a triangle. So we have to think, what is the formula for area? Area equals the base times the height divided by 2. Now we know the base here is 6 feet. That's the base of this triangle. We also know it's isosceles. There are these two congruent sides that are 7 feet. But we don't know the height. Heights are always perpendicular. So now we can start seeing the connection to Pythagoras. Notice that I've started solving this problem even though I'm not sure what I'm about to do. I'm just writing down the things that I know. I know the formula for area. I know that the other side is 7 feet because of the tick marks. And I know that if I'm going to use this formula, I have the base, but I don't have the height. And I'm labeling this side that I need, but I don't actually have it. Now I can see that I almost have enough information to use Pythagoras on this right triangle. These are both right triangles. But I only have one side. I have the hypotenuse. I have to remember that in an isosceles triangle, the altitude is also a median. And these parts are congruent. So if the whole side is 6 feet, then half of the side is 3 feet. And that means this right triangle has two known sides. One of the legs, 3 feet, and the hypotenuse, 7 feet. So now I can solve for h. H squared plus 3 squared equals 7 squared. H squared equals 7 squared minus 3 squared. I subtracted 3 squared, or 9, from both sides. And I'm going to do what I did on the other page. I'm not going to put 49 minus 9, even though it's kind of easy to do in our heads. I'm going to say h is the square root of 7 squared minus 3 squared. Well, we'll say it's the square root of 40, and we'll approximate that on the calculator. That's approximately 6.32. Which kind of makes sense, because the square root of 36 is 6, and the square root of 49 is 7, so this is in between 6 and 7. Let's just go over this one more time. This problem started out without telling us anything about Pythagoras, just asking us for area. And we had to write down the formula for area. We had to mark the triangle with what we knew. It's isosceles. We were given an altitude because it's perpendicular. And we had to remember that the altitude of an isosceles triangle is also a median. It divides the side. It intersects into two congruent parts. So 6 is divided into 3 and 3. Once we had that, we had enough information in this isosceles triangle to use the Pythagorean theorem. But we had to do a lot of work first. I almost forgot. I was so busy finding the height, I forgot why I was finding it. I was finding it so I could find the area of the triangle. The area of the triangle is the base, the whole base, 6 feet, times the whole height, 6.32 feet. And I'm going to do that on my calculator. 6 times 6.32. And that's 37.92. Feet times feet is square feet. So, after all the work to find the height, I had to remember that the question was area. And did I find the area correctly? It's the base times the height divided by 2. So don't forget to divide by 2. .96 square feet. We had to use a lot of information to find the height. Once we found the height, we had to remember to find area. And when we were finding area, we had to remember to use the correct formula.